Next, we have Binoy Thomas, a SaaS architect at IBM. Binoy will present on navigating GenAI, new responsibilities for DevOps in the age of LLMs. Let's give him a warm welcome.
Hi, good afternoon. I'm Binoy Thomas, SaaS architect, IBM ISL, India Software Lab. So this sleepy afternoon, we have a sizzling topic, navigating GenAI, new responsibilities for DevOps in the age of LLMOps. So I'm not going to do a deep dive in any particular pipeline as such, but I'm trying to build a curiosity in our DevOps fraternity to be part of the history, what we are going to see, what we are seeing in LLMs nowadays. So as we know, LLM is very common, and or AI is very, a kind of a part of our life, like mobile phone. Even a first standard kid in nowadays can do their work done without their parents knowing about it. So it's that common. As we know, these language models are available even from 1990s, and those were statistical language models, and it was not so popular. But when, from the 2090s or 2020, when OpenAI started with GPT, especially ChatGPT in 2022, browser-based LLM models they introduced, then ChatGPT has taken the common population by storm. In the sense, without knowing much, everybody can leverage the advantage of LLM. And if you look back 2022, what happened, that was the year, a lot of open source communities started giving their LLM models in Apache license, so that everybody can take the base foundation models and train on top of that. So if you look at the ChatGPT made the LLM models very popular. They later made or helped the development community to thrive in LLM technology space. And if you look at from 2020 to 2024, just in 2 years, by looking at McKinsey report, the volume of business in LLM itself is around 6.5 billion. The number doesn't show us properly, but that is the number we have. In another close to 10 years, probably by 32 or 34, they are projecting it would grow up to $65 billion business in LLM ops. It's LLM itself. So whatever we can see from the chat bots or whatever, all automations companies can leverage upon. So that's the kind of business opportunity we have. So what does it mean? As DevOps fraternity, we have a lot more to do, and we have very prospective future on top of that, and then how we can be part of the journey. So this is what we are going to see in another 15, 20 minutes. What's LLM Ops definition, and then LLM Ops is all about model training. In my perspective, it's not, that's the core of the LLM model training. But if you look at it, there are a lot of stack. So as a DevOps, right, from the data pipelines, we had a lot of talking about, even the previous session, how they are building up their own data lakehouse and data pipelines. So all that stack is part of the LLM journey. And that's how we can be part of the DevOps evolution, and then we'll just see a 100-foot view of LLM Ops. So it adheres the principles of DevOps and streamline the development and deployment process in AI model. So it's nothing new. So whenever we see a term ops, so this is the expectation we have. And why we need, since if you look at the solutions out there in the market, MLOps means the Databricks ML flow. So means can I take the LAN chain and then train myself? So why do we need all of that? But when we talk about the enterprises, it's about how the security can be assured of, means how you will monitor the drift, or how we can explain the, means something happened, so explainability of the models. That's all comes in picture. That's where the ML DevOps comes in, means becomes very important. So like OpenAI's ChatGPT in production, that means those kind of the large deployments, right? So without a proper specialized DevOps teams, it will not going to happen. So that's where the specialized team is called LLMOps. And this topic we have already covered, kind of why we need. So there are a lot of, means especially in the UI, AI, means there are some complaints coming up. It's something Europe AI Act, and then risk management, mitigating how the bias and drift. And then see if you are running a business, say for example, you are answering some queries to a hospital, then your machine learning model is hallucinating and then giving some kind of replay that can harm your business itself. That should not be happen. So all of that is part of the kind of management of and life cycle management of LLM. So when we look at this LLMOps, means even if you look at ML flow, so it's very difficult to differentiate what is ML and LLM. So in a very simple analogy, so if you give a picture of cat and dog, then ML can say you which is cat, and then it can analyze and classify and then tell you which is cat. But in case of generative AI, you can make the cat smiling. So that's the difference here. And so the DevOps concepts start from, how to support natural language processing, and then machine learning, and then now we reached up to LLMOps. And one major difference is the first one is how to differentiate and analyze and differentiate and then classify. But now with a large amount of data, how we can fill in, or how we can predict the future, or how we can generate the data. In the sense, how big the training is, that means how generic is data is, then your result would be better. So it's something like a layman speaking or writing a article, and a literature master writing a article will have a lot of difference. That's the difference between the amount of data you need to train the ML models. So of course, a lot of challenges are associated with it. So you won't be able to handle that much data. Means where do we collect all this data? Then how to train that. And again, training that much bigger data requires a lot of GPU. So individually, it's not possible. If I have a LAN chain and if I want to train one of the foundation model in my laptop, it's not possible. It will crash within 1 minute. So actually we need tons of GPU resources, and then model development. So to overcome that, usually what's the trend now is we'll take the foundation models. We have, if you look at the Hugging Face, by the way, how many of us working in LLM or related areas, especially, it can be prompt training or even working with vector databases. Any of us, how many of us working in these areas? Okay, we have a good number of people. So is it something with the prompt training, or in which area you're? RAG use cases. Okay. So anybody having lot of experience with prompt training nowadays? In recent article, I have seen now the bar is very low, so this is the right time everybody can get in. Nobody has means thousands of hours of experience with prompt training or anything as such. So this is the right time. So this is the pitch I want to make. This means everybody wants to be curious and then try ourselves, because this is the future in front of us as a software engineers as a group. And to continue with that, what we do, we take the foundation models and then fine tune based on our requirements. So we have, if you take a foundation model and then if I want to run a hospital business, then how do I to train that data, fine tune the model with specific data sets we have. And then that's how we leverage the foundation models. And then deployment, ethics, all of that we have touched upon, but in a business perspective, this means ethics. Why do we need ethics? So it should not be. The main issue is LLMs are not discriminative in the sense it's not classifying what is the actual data, but instead it will create the data for us. So that the data created, we need to make sure that it's adhering to our business ethics. So at least it should not hamper your business in anything, because the LLM is going to talk for you. And if you look at LLM models, there are multiple solutions out there. One is one of our friend here having a lot of experience with RAG use cases. That's the one typical example everybody uses. For example, you might have used a lot of chatbot replies. So what happens when you give any particular query, right? It can answer based on the kind of training or that has been trained with. But what if it doesn't have the data for a particular, for example, you have a chatbot for a hospital and then recent doctors list, it may not have, it was not trained with. So what happens, so then probably that's where the RAG augmented retrieval help you. Then here, if you really look at it, this is the kind of a typical scenario where we have a embedded databases, or what we call it as a vector databases. If you take the IBM example, we use Milvus databases in our Milvus database in our solutions. So it can take any of the data. It can be photos or condensed PDF, anything. Then some embedding means we can choose the embedding model what we need to, and then we load with the databases here. So what happens whenever we have a change in our database, for example, that doctor's list or something, that can be fed to the embedding model. And then when we have a user query that one, then that question will again getting embedded with the same model, because it means whatever data we have, if we have a collection in the vector databases, so everything should have the same embedding model. Then only it can understand from the vectors, because one embedding models can make a 384 dimension and another one can make a BERT model, and all it will make 1024 vectors. So you need to have same embedding model. Then what happens, it will make a query with, it will embed that question and then make a similarity query in the vector DB. So that is not a lexical query. It will make a similarity, means which is the most similar one. Then you can select, I need 2 queries or 1 query, 1 result or 2 results. So that result will become your context. So now LLM got, okay, you need a doctor's list, and then this is the particular cardiology or something. So then LLM get to know, okay, your context is you want to search it in the cardiology department, and then it will means once you get the context, then you will be able to answer it better. So this is the same way means in our human life also. Um, if you ask some question at home, right? So then if somebody is asking it the same question at office, the context is different, and then you may think, okay, what's the kind of question he is asking for? So context is very important to make out something in a generative scenario, means to give you a proper result back. So most of the cases we see some chatbots, and then how we are getting the result back, and then I want to just have a kind of a close look at it, how it would look like. I'm not sure whether you will be able to read it, but in a sense, what I'm going to do is I have a small document which says how to use the IAM, Identity and Access Manager configuration, and then give some kind of a explanation of what means. If I want to use IBM IAM, how to configure it, where to look at in the cloud, in IBM cloud, and that data becomes the context, and then that data I'm going to vectorize and then keep it in the vector database, and then I use one of the foundation model in watsonx. Watson is nothing but watsonx.ai is IBM's AI platform, and then use that context to augment my result. So here, if you look at all the, I'm just importing the modules, only one means probably pandas and everybody is aware of. So here we have PyMilvus. This is nothing but the Python library to interact with Milvus databases. So here what I'm going to do is, this is my document, in our older example, the hospital documentation, the same way I have the document for the IAM. This is what I'm going to, I have only 4 documents. So document would like a title, and then there is a passage about how to use the IAM, but it doesn't give what is the exact steps to retrieve the IAM or how to configure the IAM. So this is nothing but the collection name. This is where I'm going to keep the document, and then this is the dimension. So if we look at it, I'm going to use an embedding model called means my embedding model is going to use 384 dimension, and then this is where we need to, means if we have millions of records, this is for documents only. But in our production scenarios, I have met with millions of documents, 100 million kind of, that's the kind of volumes we have. Then we need to see which index type means will be fitting for a particular use case. That's where we need to work with the data team, and then data analyst and data engineering team. So they will have the perspective, and then we have to design accordingly. So this were in a typical scenario how the ops people or DevOps people will work with the different engineering organizations. So here, what I'm going to means I have ingested 4 documents, and now this is going to be my question. So the question part again, I need to embed. So the next steps, what we can see, I'm embedding the same, embedding the questions. So that embedded question is going to be my the query to the vector databases. And then see the limit is 1 here. So since I have only 4 documents, so there is not much, it will not make much sense if I give 2 also, because I have only 1 matching document. But still it will give all 4 documents because it's all working with the KNN, and so what is the nearest this one. So it will find some relation in all non-related as well, but I am taking the only 1 result, and which should be the right answer. So this time what we have seen is I have run the query directly in the vector databases, and then now I'm going to use LLM foundation model. Here I'm using the Granite model. This is this model is from IBM. This is one of the IBM foundation model. Then here what we can see is I am going to get the result from the vector databases. And if you look at this one, how I have embedded is the result and then question back. So the first result is going to be the context here. So if you have a close look at this context, I am not directly telling how to configure the IAM, but it's giving a generic passage saying, if you want to work with IBM watsons.data or watsons.ai, you need to configure the IAM. So, but when I run the same query to the LLM model, then what it returned is a nicely documented steps how to create a IAM in IBM Cloud. So if we compare with what is there in the vector databases, it's just a passage, but what it could able to make out is we are asking for how to configure the IAM in IBM Cloud context. So if we go further, so this time what I am doing is I have overwritten the variable from the vector databases by removing the context. I'm just passing the questions only now. So I have removed the context. Now we will see what's going to be the answer here. So here if we look at the same query, I passed it to the IBM Granite foundation model. Now the same query returned me without any augmenting what is there in the foundation model itself. Now it is giving the answer for how to configure the IAM for the AWS cloud. So actually what happened, probably that model might have trained with the AWS context or AWS data set. So that's what the foundation model was. But when we augmented the result with I am asking the same IAM configuration in the IBM context, it augmented the result for me. That's what usually happens in all of the chats we have seen, we are seeing nowadays. So anybody heard about the grounded chat? We all used chatbots, but anybody used the grounded chat? So in the grounded chat, the same happens. So what happened, usually when you ask for some question and then getting the chat, and then if you are not getting the result, right? So on the fly, for example, if I want to make or understand more about a particular company's quarter result, then that quarter result may not be there, means it's not trained with that. So on the fly, you can upload the PDF in the chat window itself. So behind the scene, what happens, it getting added to the, embedded to the vector databases, and then that will become your context, and then it will give all the, what kind of results you want with respect to that company's got result. So on the fly, you can upload the document and then getting embedded. That's what the grounded chat nowadays we can see now. So this is just an example of how it is kept it in the what is there in the vector database, how it is kept, or how, what is the schema of the table. So time is over, or? So this is what I want to take it to a couple of minutes on this. This is the gist of our talk. So if you look at any LLM model, right? So I didn't specify any particular solution-based technology. Any particular solution here. But if you really look at, this is the foundation models we have. So if you want to train anything from the scratch, you can go ahead with the LangChain or Hugging Face transformations and all. But in practical scenario, practical case, what happens? So we can take these foundation models to some of the pipeline, for example, MLflow or IBM Cloud .ai. So this what happens, you can prompt your foundation model with your questions and then evaluate. If you are happy with the result, you can promote that model to the production. Otherwise, you can again go back to the human feedback lab, prompt engineering, or you can do with kind of a different types of fine tuning. So again, it will evaluate. So, or if you look at MLflow or different solutions out there in the market, right? This kind of pipelines are all there in the market. All that we need to go and explore it. Even if you look at IBM.ai also, we have these solutions out there. And then we have governance pieces. What we talked about what governance pieces does. So it will look for the drift, all of that, and then look at the how good the result in the production. How the model inference is nothing but in the LLM terms, how the new documents getting generated, right? How relevant it is, so how good it is. So that talks about the inference of the LLM model. And then comes to the data side of it. Then we have Lakehouse, and then which can have vector databases and distributed queries like Presto, which can support all Parquet table faces and all. But if you start working with any of this one, right? So vector databases has its own challenges because it doesn't do any lexical insert. It will try to load the entire collection. If you have 1 TB of collection, so essentially it means that you need to have a 1 TB of memory in your system. So that's the kind of challenges we have. So means even when our team is trying to find out how to solve this kind of challenges in hosting the vector DB and all. So what essentially means that we have a lot of challenges in these areas, and then that means we have a lot of opportunity there. So I want to make, I was trying to make a humble effort to make ourselves curious about this LLM landscape, the LLM technology landscape. So with that, let me conclude. Thank you. Any questions?
Thanks a lot, Binoy, for the amazing session.